All right, we're going to go get started with another practice exercise today. So if you would turn to page 9, we're going to do exercise 27. Exercise 27, just got some add, subtract, multiply, a little bit of divide, with some decimals, some fractions, kind of a mixture of things there. Exercise 27. No calculator.
Mixed numbers?
Yeah, mixed numbers for your answers, not improper fractions. All right, go ahead and get started.
Are we on 27?
27. just another minute to be working on this exercise. Go and put your pencils down, even if you're not finished, and take a look at these. And Michael was first. Let's see how he did. You check your answers as well here on exercise 27. Top row, Michael, when you added those two mixed numbers, you got?
11 2/3.
That is not what I had. Abby?
12 and 19, 24.
12 and 19, 24 should have been our answer. So we'll stay with Abby. On the next one, when you subtracted those mixed numbers, what did you get?
3 and 7 ninths.
3 and 7 ninths. And then when we divided by 3/4, so we don't really do that, you got 2. All right, next row going across, we had some decimals we had to multiply.
0.0431.
Oh, really close.
Okay. No.
Are you perfect so far?
I was, but that was close enough.
You got 0.0431?
No. I had 4.41.
Should be 0.0441. 0.0441 should have been our answer. All right, so candy's off the table. Let's kind of go around here. That next multiplication, Brecken, what did you get? Skipped that one. Dylan?
I got 6.
6 is correct. You added together those decimals. What did you have, Lana?
15.415.
Good, 15.415. Next one should be really easy if you remember a little trick for dividing by 10, Josh.
3.46.
Just move the decimal one place, 3.46. Had another subtraction involving decimals. Let's go back to Brandon.
1.3272.
1.3272. You can't divide the decimal, so you're going to have to move the decimal in both cases. Make it a 1,768 divided by 52. Adam, did you get that one?
The 1.3.
No, the last one on the third row.
Yes.
What'd you get?
34.
34 is correct. Then going across the bottom row, Noah, what'd you get for 10 minus a half? 9.5. That was probably the easiest one on here, besides the 34.6 divided by 10. Adding some more mixed numbers, let's come back to Michael.
4 and 11 12.
4 and 11 12. And Abby, finish us off. What did you get for the very last problem? 10 is correct. Anyone perfect on all the ones you did? Maybe you didn't get them all, but you were perfect on the ones you did. A couple of you. How about just miss one of the ones you did? All right, just missed 2. How many?
6.
You're kidding. Okay, questions on any of them? Okay, questions on the exercise. Any problems we need to see worked? All right, pass those in if you would, please. And take your homework handouts out. You did handout number 14. It looked, not like that. It looked like this. It was side 2, the back side of the handout. All right, we would go to hold that up so that I can see that it is completed. I'll leave them up in the air for a second while everyone gets them out and ready. Bueno, bueno, see ya. Abby like, ooh, he's starting to check mine. Let me drop it. Be like, oops, my bad. Maybe you won't notice. Just kidding. Good. And I was like, here, I'll hold it away from you. You'll just acknowledge I held something up. All right, she's good. I'm just picking on you. All right. So let's take a look here. We have these 2 lines that were parallel, and I said that's kind of a clang, not quite a clang. What did I mean by that, Dylan? I got parallel lines. What did I say we should be thinking?
Never intersect.
Well, that's the definition. Yeah, I don't care about that. For a proof, when I see parallel lines, what thought should be going through my mind, Josh?
Like alternate interiors,
alternate exteriors, corresponding, and
What about all those things?
finding.
There we go. I'm going to get some equal angles. That's kind of the gist of it. When you see parallel lines, you should be thinking, I'm going to have some equal angles here. And so we have these two parallels, M and N. We had a transversal AD. We had what appears to be a longer transversal BC. And the way BC went through, they intersected at a point P. And I said they intersect so that AP and DP are equal to each other. And then I numbered these angles 1, 2, 3, and 4, 5, 6. All right, so obviously your first statement that you should have written down, I'm going to cheat just a little bit here. First statement would have obviously been class just the given, M is parallel to N. I'm going to cheat just a little and shorten this to just AP equals DP. Obviously we see that AD and BC intersect, but that's significant. By the way, that would make P the what class? Midpoint. Now, I don't need to say that. It wouldn't be wrong to say P is the midpoint of AD, definition of a midpoint. It wouldn't be wrong. I just don't need that. Obviously, the first reason class, given, okay. And then number 2, of all the angles I could have used, I went ahead and said, I want you to get angle 1 equal to angle 5. I want that to be statement number 2. What would be the reason for angle 1 equals angle 5? Noah?
Alternate interior angles and parallel lines are equal.
Good. Alternate interior angles, because that's what they are, but they're not equal just because they're alternate interior angles of parallel lines are equal. Or perhaps you could say, if lines are parallel, then alternate interior angles are equal. You could say something like that. How many had that for your reason? All right, questions on why 1 and 5 are equal. And then I just kind of left it there. That's all I did for you. Of course, we haven't even thought about what we're trying to prove. We're just, hey, I got parallels. Clang, I know I'm going to have some equal angles. Oh, he told me to get these two angles equal. Let's consider what we're trying to prove. I'm trying to prove that line AB equals CD. So here's what we're saying. Draw any two parallel lines. Draw any transversal. Draw any other transversal through the midpoint, and the segments that are cut off will always be equal. That's essentially what we're proving. I want to get line AB equal to line CD. Now we talked about a couple of ways you can prove lines equal. What's one way to prove lines are equal to each other? Adam?
CPCT,
After you get
congruent triangle.
congruent triangle. So you can get congruent triangle CPCTE. What's the other way you talked about getting lines equal? Abby?
Get equal angles in one triangle.
Good, get equal angles in the same triangle. Now as I look at AB and CD class, are they in the same triangle?
No.
So we ain't gonna use Abby's method. It's not really Abby's method, she was just answering the question. We're gonna use the other method. We want some congruent triangles, and as if you didn't already know that was coming, I told you, I want you to use angle side angle to get these congruent triangles. What two triangles are we going to want to say are congruent to each other? Lana?
The angle 3 and 6.
Now what triangles, well, I'm kind of skipping over number 3 for a minute, because we've kind of agreed we're gonna want AB equal to CD by CPCTE after we get congruent triangles by angle side angle. But what are the triangles that are supposed to be congruent?
A, B, and C.
Okay, so triangle APB is going to be congruent to, and let's see if this lines up. A has angle 1 at it. We just said angle 1 equals angle 5, so that means that the A actually matches up with the D. Because 1 and 5 are equal angles, D and A are those matching vertices. So we're going to have D. What do you think will match up with the P right here?
The P.
Probably the P. And if we wanted to, we could have said 2 and 4 were equal, because they're alternate interior angles also. And I think somebody was commenting before class that if you did, you would have side angle, and we haven't proven that works yet. I overheard somebody saying that. But yeah, so it looks like it'll be D, P, C. Those are going to be the congruent triangles, but I said I want you to use angle, side, angle. Well, here I've got angles. Here I've got sides. Lana, what are the angles that we need to be equal in order to have this angle, side, angle that I put on the proof?
3 and 6.
3 and 6. Why are 3 and 6 equal though? Because we can't just say, oh, 3 equals 6 because I want them to. We have to have a good reason for 3 equaling 6.
vertical angles are equal.
Vertical angles are equal. And there we go, the entire proof is done already. How many had
Well,
a perfect proof?
except, does it really matter if it was, the letters?
Oh, the lettering on the triangles?
Yeah.
Minus a point. So, I mean, was that the only mistake though?
Yeah.
Okay, good. Okay, so pretty much perfect, right? Torn sticker. All right. And Gavin knows what that means. All right, yeah, questions on this?
Who? Gavin? Oh.
You know
I
your
was thinking
classmate
of the different
who's
one.
watching in Japan. All right, anyway. Scotty will watch next year. Scotty knows what torn sticker means too. Anyway. He doesn't what?
He doesn't have geometry.
No, right, he's doing algebra
Oh,
2
yeah.
right now. All right, questions on this? In a perfect world, you take algebra 2 first and then geometry. It just didn't work out for the way the class schedule worked. Anyway, questions on this? All right. Go and use, actually I would say use the back of the handout. You don't have a back of the handout. We've already used it. Go and get another sheet of paper, scratch paper, some kind of paper, and let's do some more of those numerical exercises. Let's do some more of these numerical exercises we've been working on recently. Or I give you some parallel lines. By the way, if I don't give you the lines are parallel, you really can't find anything, can you? Parallel lines allow you to find things. If the lines aren't parallel, there's not much you could do. Let's suppose we have these lines, and we'll say R and S are parallel. We'll have M and N are a couple of transversals. We're going to number the angles 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't want you to find all the angles this time. But if angle 6 is 37 degrees, I want you to find two angles. If angle 6 is 37 degrees, maybe very lightly pencil in some things because we're going to use the same picture again. So don't write too dark, but maybe lightly pencil in. If angle 6 is 37 degrees, I want you to find angle 3 and angle 9. Shouldn't require too terrible much work on this particular exercise. How would I find the measure of angle 3? Joshua?
Well, isn't it like alternate interior?
Yeah, angle 3 and angle 6 are alternate interior angles. So if 6 is 37, how big is 3?
37.
37 degrees. How many also had 37 degrees for angle 3? How would I find angle 9, Brandon?
Subtract 180 from 37.
Other way around.
What? 37 from 180.
There we go. Take 137 from 180 because we know that together 6 and 9 make a straight angle because the sum of all the angles of that 8 point on one side of a straight line equals a straight angle. How big is angle 9? 143 degrees. How many have both of those correct? All right, now, forget that you ever had those angle measurements because they're null and void now. I'm going to change up some things on it. Let's suppose I know that angle 4 is 51 degrees. I want you to find angle 1 and angle 5. Suppose angle 4 is 51 degrees. Find angle 1 and angle 5. Michael, how would I find angle 1 if I know I've got a 50? If I know I've got some chalk way over here. Brecken, why'd you do that? Acting innocent over like, what am I? What am I? By the way, does angle 4 look like it's 51 degrees, class?
No.
It looks obtuse, but you know, we don't trust our eyes. That's a 51 degree angle. All right, so Michael, if angle 4 is 51, how would I find angle 1?
I found angle 5 first.
Well, we could find angle 1 even without finding angle 5. How?
That's a good question.
It's a very good question. Adam?
You could do the opposite angle, which would be angle 2 and 3.
Yeah.
When it says 2 and 3 feet.
Well, okay, you could say, but I can just find angle 1 directly. I don't need to find anything else first. I've got a theorem or a corollary that allows me to directly find angle 1 right
Not
above.
151 too?
What?
Is not 151 too?
No, no, is it 51 also, class? No.
Oh.
What did we say was true? If two parallel lines are cut by a transversal, then the sum of the two interior angles on the same side of the transversal, class, will equal a straight angle. So I know these are going to be supplementary to each other. I just have to find the supplement, which would be, back to Michael, 129 degrees. Now, is it wrong to find angle 5 first? Not at all. In fact, that's how we kind of proved the corollary, was we said, well, together 4 and 5 make a straight angle, so we know 5 is 129, and since alternate interior angles are equal, 1 equals 5, so they're both 129 degrees. So not wrong to find 5 first and then 1 by any stretch, but we could do 1 directly that way. How many had 129 for both angles? All right, questions on that? All right, now forget what you just had because it doesn't apply anymore. Now, let's suppose we're given angle 5 is a 60-degree angle. Angle 5 is a 60-degree angle, and we know angle 3 is a 45-degree angle. I want you to just find angle 2. If 5 is 60 degrees and 3 is 45 degrees, find angle 2. Impressive, Dave. Impressive. No, it's truly impressive.
I was there.
You're a copycat, Michael. Brandon Dylan's like, I'm going to one-up them all. Ooh, ah, ooh, ah. Forgot to move my hand first. Pencil shards just sticking out of his hand. Oh, it's just trying to be cool. All right, so we know that 5 is a 60-degree angle right here. We know that 3 is a 45-degree angle right here. There's a few ways we could go about finding angle 2. Talk me through your thoughts here, Josh. I think about 3 or 4 different ways I could find angle 2. All I need is one of them. You do have to find something else first, if that helps. You do. You can't find angle 2 without finding something else first. Dylan, help him.
6 is alternate interior.
So therefore,
6 is a 5 years.
okay, Josh, does that help?
Yes.
Okay, so how would that help me find angle 2?
Because all of the sides in a triangle will like angles equal a straight angle.
Good, the 3 angles of a triangle equal a straight angle. So if I know that this is 45, this is 60, how many degrees does that leave for angle 2?
75.
It leaves 75 degrees. That's one of the ways I was thinking of defining it. Anyone else think of a different approach besides finding angle 6? Anyone else do it a different way? Let's see, Noah.
Since angle 1 and 5 are equal, angle 60, and R is a straight angle. So
It's basically the same approach, but now you're doing with these 3 angles adding up to the straight angle and these alternate interior angles. Good. Anyone else think of a different way that we could have approached it? Anyone else got a different way we could have approached it? I could say this. I know that this entire angle here, 2 and 3 together, is going to be supplementary to 6 because the sum of the 2 interior angles on the same side of a transversal always equals a straight angle. Well, what would be supplementary to 60 degrees, class? 120. So if I know that collectively it's 120, and I've already got 45 spoken for, I could find the 75 that way. The other way we could have found it was to say, well, I know that this is going to be supplementary, so it's 120. Therefore, this is 120, and therefore we have 75. So 4 different ways you can approach the same problem. How many had 75 regardless of the way you thought it through? All right, let's do another one. And I think I'll redraw the picture because it's all starting to get messy here. Might be faster to do that than to try to piece the pieces together. We have R, S, M, N, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay,
Redrawn.
you don't necessarily have to if you can manage to erase your light pencil markings. Let's suppose we knew that angle 9 was 130 degrees, and we knew that angle 1 was 55 degrees. I want you to find, once again, angle 2. Abby, there's a few ways you could approach this one also. How did you think it through? Talk me through your thoughts.
I said that angle 6 was 50 degrees, so that makes angle 3 50 degrees.
All right, so she said, well, I know 9 and 6 make a straight angle, so if 9 is 130, 6 is 50. And then you said?
Angle 3 is 50 degrees too.
Angle 3 is also 50 because it's alternate interior to 6. And then I assume you said I got a straight angle up here. And so you pieced them together and you found angle 2 is 75 degrees once again. Not because it's always 75, but it just happened to be here. How many found it the same way? Anyone go the exact same way Abby did? Okay, so there's a couple people that think like Abby. Anyone approach it a little bit differently? Dylan?
I said that angle 1 plus angle 2 is equal to angle 9 because they correspond.
There we go. The corresponding angle of 9 right here is the combined 1 plus 2, right? They're corresponding angles. So collectively, this all adds up to 130 degrees. Well, how many degrees are we missing? We're missing 75 of them to collectively equal the 130. That's the way that I did it also. Doesn't make Abby's way any less valid. Just makes our way quicker. But good. Let's see. Can I think of any other ways to go about it? Somebody else got another way? Brandon?
I mean, you can start it off with saying 50, and angle 6 equals 50 degrees, and say angle 5 is equal to 55 degrees.
That's true, yeah. So if this is 55, this is 55. If this is 130, this is 50. And then once again, you've got those 3 angles of the triangle adding up to a straight angle. So a few ways to approach it. How many got 75 regardless of the way you approached it? All right, questions? All right, let's do one more. Once again, I'll redraw the picture since I did a whole lot of marking on there. R and S are parallel. We have these transversals, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And this time, let's suppose that angle 2 is not 75 this time, it's 85. And angle 8 is 103. I want you to find angle 9. I just thought of a way. I was like, ooh, I could tell it that. No, we haven't proven that works yet, so I can't go that route. Never mind. There are still a few ways to approach it. And Brecken, talk us through your thoughts.
I've completely blanked out on this one.
Well, let's find something. I mean, that's really truly, that's the main approach is find something. I mean, you gotta know at least one other angle in this picture.
Maybe 7.
Okay.
I'm just gonna write these down.
I mean, you can use a calculator. This is math. You can use a calculator for things like this. On the exam, for instance, on Friday, if you happen to have problems like these, you can use a calculator.
77.
Okay, so you know that angle 7 is 77 degrees, 777. Lucky number. Okay, that's at least a start. Can you find anything else? I mean, I know our goal ultimately is to find 9, but can you find anything else?
I guess 5 now.
Okay.
103.
Hey, you know, hey, that's still a start. Okay. Anything else?
I guess you could do the triangle now.
Okay. So,
Can somebody add this for me?
do you have a calculator?
562.
They add together to get 162 so far.
Okay. Angle 6 is 18.
Okay. We're getting closer. We're like, at least now we're on the same side where 9 is. We were over here before. Now we're on that side, so we're making progress.
You do 180 minus 18 to get 162.
There we go. That's correct. How many had 162 degrees for angle 9? Anyone able to do it without finding so many angles? But it's not wrong. That's the point, right? It's not wrong to do it that way. I said that angle 8 and 2 and 3 collectively were corresponding angles. So I said, well, if I got 103 here, then this whole thing's 103. That's going to leave me with 18 degrees right here at number 3, which means 6 is 18, which means this is 162. So I didn't find any of these, but I found the others. You know, could have gone, okay, I know this is 77, therefore this is 77, therefore this is 18, therefore this is 18, that's 162. There's a few ways you could have gone. How many got the 162, regardless of the way you approached it? All right, questions on that? All right, we practice more of this in our next lesson, assuming we have time, but you will have a section somewhat similar to this on your exam on Friday. For now, let's do a little bit more work here. So let me go ahead and give you another handout. And to Gavin, it's handout number 15. Handout number 15. So there's 2 sides to the handout for those in the classroom. We're doing the little easy one first. We're doing the little easy one first because, let's be honest, why not? All right?
Only 3 steps.
Yep, 3-step proof. And at your seats, go ahead and look it over and do the proof, and then we'll go over it together. So you got a couple of lines intersect each other at some not so, a sort of random point M. You got a perpendicular and another perpendicular. Now, obviously, you could do this in a lot more than 3 steps. We're just going to do it in 3 steps. I'm going to cheat on the given just a little bit here and just go to the main part of it, which is that I got a couple of perpendiculars. Normally, class, if I see perpendicular in the given, clang! Right angles. And normally if I see right angles, clang! Equal angles. And, or right triangles or something, right?
Mm.
Normally, too, in most of my proofs, at some point I end up getting a couple of triangles congruent. I mean, look at this. Does it look like I'm going to get congruent triangles? It don't look like congruent triangles on there at all. And I'm not trying to prove congruent triangles. But I didn't go with any of the clang that we normally go with. I went with kind of a different clang. I said that CA and DB were parallel. Just like that. What reason could I give for saying CA and DB are parallel? Just like that. Got a few hands. If you're stuck, you could go to your class notes and you have a matching section. You have 6 ways to prove lines parallel. It's got to be one of them 6. So if you're like, I don't know what the reason is for number 2, then I would go back through your class notes right now and look them up and see which of those 6 ways to prove lines parallel is the one Mr. Dasky was thinking of when he came off right off the bat. Boom! CA and DB are parallel. I mean, I know they kind of look parallel, but why are they parallel? Probably the last thing you wrote in class notes.
Yeah.
So find the last page with writing on it in class notes, and that should have kind of like a matching. So you just pick one out. Which of those did he use here?
Maybe.
And Lana is eager to answer. Lana, which of those ways would I be able to answer? Just right off the bat. CA is parallel to
They're
DB.
parallel to the same line. No.
Well, have I said that CA and DB are parallel to some other line, though?
No.
No, I didn't say that.
Well, maybe the perpendicular thing?
What about the perpendicular thing? Because I do have perpendiculars in here, so that sounds like we're on the right track.
Perpendicular to the same line?
Are they perpendicular to the same line?
Probably.
Are CA and DB perpendicular to the same line?
Yeah.
They are! So what's my reason, Lana?
So what is that? They are perpendicular to the same line?
Therefore they are
Parallel.
parallel. Lines perpendicular to the same line are parallel. How many had that for your reason? Now, could you say, clang, I have right angles A and B. And then clang, A and B are equal because all right angles are equal. And then, ooh, A and B are alternate interior angles of this transversal. Therefore, the lines are parallel. You could have. It would have taken 4 steps instead of 2, but you could have done that same thing, though we did all those steps when we proved that lines perpendicular to the same line are parallel to each other. Now, why did I go back in parallel lines? Well, what am I trying to prove, class? I'm trying to prove I got a couple of equal angles. And if I want a couple of angles equal, I could try to get congruent triangles CPCT, but they don't look real likely. I could try to show their opposite equal sides in the same triangle, except they ain't in the same triangle. Or another way to prove angles equal is to get parallel lines. Because what do parallel lines give us? A bunch of equal angles. In this case, why are angles C and D equal to each other? What kind of angles are C and D? And you may want to turn your paper like this in order to see it better. But why are C and D equal angles? Noah? Good. This is a transversal right here. CD is the transversal. They're both between these 2 lines, so they're interior, and they're on alternate sides of the transversal. So we will say number 3, Noah.
Alternate interior angles
Huh?
of parallel lines.
Are equal. And I just realized I never expanded the camera view, so sorry, Gavin, but you've been hearing all the reasons and seeing absolutely nothing. All right, there we go. Now you can see it all. Anyone get the proof before we even went over it?
No.
All right. Questions. I wanted to show some things. So a really simple proof, but I wanted to show some powerful things in here. The thought of, yes, perpendiculars mean right angles, but if you got a couple perpendiculars to the same line, that could give you parallels. And if you need equal angles, there's now another way to get them. Get some parallel lines can often give you there some equal angles. Questions on this very short first proof? Alright, flip the page over. Flip the page over then. And let's look at the back side. A little bit longer proof going on here. And to take a moment to look it over while I get some things copied up here on the chalkboard. So look at the picture, look over the given, look at what you're trying to prove, and start forming a little analysis in your own mind. We'll do a class analysis in a moment. So you've got a shape. How many remember what this shape would be called from your junior high days? At least it looks like a parallelogram. Kind of looks like a parallelogram. Doesn't say that it is, and we don't really know anything about parallelograms yet anyway in this class, but whatever. And we've got this, do you remember what we call a line that joins non-consecutive vertices? Diagonal. So we've got this diagonal, and it says that DE, so there's this certain distance from D, and there's that exact same distance marked off here to a point called F. So DE and BF are equal. And then if we happen to know that from these, the lines going to the opposite vertices, if those lines are also equal, and if somehow these two lines happen to also be parallel. Okay, so a lot in the given there. DE equals BF, AE equals CF, and AE is parallel to CF. So a lot in the given. More realistically, this is probably how this picture would have been constructed. You would start with a diagonal, mark off equal segments, draw a random line, draw a parallel to that and make it the exact same length, and then go around and connect the dots. That's probably more how the picture was formed. So we're kind of looking at the outside already being present. Probably the outside came later, but don't worry about that. What are we trying to prove in this particular proof here? Josh?
AD equals CB and AD is also parallel to CB.
So when these two lines were drawn, they're equal and they're also parallel. Now, if it is a parallelogram, y'all might remember, then they'd be parallel lines, they'd be equal lines, but we're trying to prove that they are indeed. I guess kind of, in a sense, proving we have a parallelogram, in a way. All right, so you got your first statement of reason down? Yes? No?
Yeah.
Yes.
I numbered a bunch of angles here. I numbered this angle 1, 2, 3, and then I switched sides of this diagonal, went 4, 5, 6. I said right off the bat, number 2, that angle 3 had to equal angle 4. Well, how would I know that 3 and 4 are equal angles to each other? Michael?
Because all interior angles and parallel lines are equal.
All who what?
Interior angles and parallel lines.
Alternate interior angles, right? Here's the two parallels. Here's a little piece of the transversal. They're both between the lines. Now the lines stop, they dead end, they weren't extended here, right? But we still have them between the lines and on opposite sides of the transversal. So yeah, alternate interior angles of parallel lines are equal. Again, kind of a bit of a clang in that you need some equal angles. I'm telling you 3 and 4 are going to be the best ones. And then I said this, for number 3, I want you to make a statement based on this fact, that the sum of all the angles about a point on one side of a straight line equals a straight angle. What statement do you suppose we would make with that reason? Looking at the picture, where do you see some angles that are about a point on one side of a straight line? Brandon?
Angle 2 and angle 3.
Okay, so I could say that angle 2 and angle 3 add up to the sum equals a straight angle. How many others think of the same thing? Say that 2 and 3 together make a straight angle? Any other thoughts, Brecken?
Angle 4 and angle 5.
Yeah, same reason, angle 4 and angle 5 add up to a straight angle. Because immediately after this, I turn out saying that angle 2 plus angle 3 equals angle 4 plus angle 5. Reason. Abby?
All straight angles
Yeah, these two sums are straight angles, and all straight angles are equal. Now, what do you suppose we would state next? We've seen this pattern before. Adam, we should be starting to get a feel for this. 2 and 3, that adds up to a straight angle. 4 and 5, that adds up to a straight angle. So 2 and 3 collectively is the same thing or equal to 4 and 5 collectively. What do you suppose comes next? Keeping in mind what we said for statement 2.
Angle 2 equals angle 5.
Good. The 3 and the 4 that we said were equal could be subtracted, leaving you with an angle 2 equal to an angle 5. You don't have to have them spaced out like that because of
Subtraction axiom.
the subtraction axiom, where we can just write the word subtraction. If equals are subtracted from equals, the remainders are equal. And that's significant. Just look at the picture for a moment. Why is it significant that 2 and 5 are equal angles? What do we see right in front of us here? Class? I see side angle side. Right there. Sides with angles in between them equal. So number 6, and I said it, and you shouldn't have needed the help, but I said the triangle, help all of y'all. That one?
Yes.
Okay. And what's the reason, class? Now, why do you suppose I take the time to say that this little triangle is congruent to that little triangle? Well, what are we trying to prove, class? First of all, AD equals CB. I want these two lines equal. And one of the best ways to get lines equal, class, is to get and then use. So what is statement 7, reason 7 going to be, Noah? Did I put that in there already? Oh, I was like, where'd you get the angles from? Sorry, I was just thinking AD equals CB. Reason? CPCTE. Now, Noah said something about angle 1 equals angle 2. I'm like, who cares? Angle 1 equals angle 6. You didn't say 2. Angle 1 equals angle 6. I mean, I got the first thing, right? My next question was going to be, how do I go about getting these two lines parallel? Well, oftentimes, what does it take to get lines parallel? To prove lines parallel. I gave you 6 ways to prove lines parallel, but 3 of them involve what? What's one of the best ways to prove lines parallel? Get some angles equal. Either alternate interior, alternate exterior, corresponding. Get angles equal. Parallel lines give you equal angles. Parallel lines are often gotten through equal angles. And so I said in number 7, apparently, that angle 1 equals angle 6, also by CPCTE. Are those angles 1 and 6 special enough to give me parallel lines?
Yes.
Why? They're alternate interior. Here's the parallels. Again, turn your paper sideways if you need to see it a little bit better. Turn it like this, and you can see the 1 and the 6 are your alternate interior angles. So therefore, number 8, I do indeed have parallel lines because, as it apparently already says on the paper, I give you guys way too many helps on here. You didn't need all this help. You would have had it without it. If, when 2 straight lines are cut by a transversal, a pair of alternate angles are equal, then the lines are parallel. And we're good to go on the proof. Questions on that? Yes, ma'am.
Are 3 and 4 really necessary?
Well, could you get 2 and 5 equal without it?
Yes.
You could. Because what are 2 and 5?
Alternate exterior.
They are alternate exterior angles. So we could have skipped all of this. The reason I didn't, I wanted to give us practice with the substitution or the all straight angles are equal and the subtraction. But no, absolutely great observation. Anyone else notice the same thing? We could have gotten 2 and 5 equal without the 3 and the 4. No written homework tonight other than be studying your notebook for the exam. Don't forget your notebooks are due Friday. Before you leave, let me give you back your quiz from yesterday, and you'll be good to go.